Hello and welcome. I am Dr. Pauline Fu. In this video, I will introduce Box-Jenkins methodology, also called ARIMA methodology. This method is used to forecast time series data. Recall that you have learned moving average, exponential smoothing, hot winters method, as well as the decomposition method. All of these methods require independent variable x. So what is the difference between ARIMA method with the method we have learned before is that ARIMA method does not need independent variable. It is just based on data itself. Okay. So now I will introduce some new terminology. So first, what is ARIMA stand for? It is stand for autoregressive integrated with moving average. Okay. There are different situations. There are different terminology here. One is the P, Q, and also there is a D we are going to introduce later on. So let's do the P first. P's order, autoregressive model, means you set up a model with time series YT with 1 time lag, YT minus 1, 2 times lag, YT minus 2 until P times lag. And epsilon T is the error term, okay? Phi 0 is the constant. Phi 1, Phi 2, and Phi P are parameters need to be estimated. Okay, so for example, if you want to set up a relationship between YT and YT minus 1, you can just use this model here. So in this case, P equal to 1. It is the first autoregressive model. Okay, so similarly, when you have a P equal to 2, second order autoregressive model, it is this part here. This is the second order, okay? The relationship between YT and YT minus 1 and YT minus 2. Okay, so this, the first situation when you have P equal to 1, we actually call it is AR1. Okay, and the second situation is AR2. So next, we want to establish a model. The model has connection with the error term here, okay? And this model is MA, moving average. A new terminology is the Q, okay? So Q is, when Q equal to 1, when Q equal to 1, you just have this part. When Q equal to 1. So this is a first order moving average model, MA bracket 1. And when Q equal to 2, you have this part here, Q equal to 2. Okay, the model becomes MA bracket 2. Okay. So this epsilon T is the error for T time period, okay? And this epsilon T minus 1 is the error produced between actually YT minus 1 and YT minus 2. If you combine those two models, you get a ARIMA model, okay? So if you can see, you just combine the AR model with MA model, you get this model here. In practice, usually P equal to either 1 or 2, Q equal to 1 or 2. We seldom go beyond number 2. and the residue square mean, you use this formula. Okay, so that is the little introduction about ARIMA model. It is just use data itself with time lag and with the errors. We have a theoretical model to show you how do you know you use the first order or second order AR. If you look at this diagram shows autocorrelation, and this one is a partial autocorrelation. If the autocorrelation is dying out to 0 quickly, and the partial correlation have cut off at 1, in this situation, you use AR1 first order autoregressive model. Okay. On another hand, how do you use second order autocorrelation model? If you have the autocorrelation dying out and the partial autocorrelation has 2 spikes, okay, 2 cutoffs here, you use second order. So this is for autoaggressive regression. So next graph show you when do you use moving first order, moving average, MA, when you have autocorrelation cut off, just 1 spike, and the partial autocorrelation dying out to 0. In this case, you use MA1, okay? And when do you use MA2? When you have the 2 spike, see this is 1 spike here, another spike here, 2 spike in autocorrelation. And the partial autocorrelation dying out to 0 quickly. You use second order, MA. And when do you use ARIMA, combine AR with MA? When you have something like this, the autoregression dying out, the partial autocorrelation also dying out, so you use ARIMA. Okay, so those are the theoretical model. In practice, you base on your data and you see you produce 2 plots. One is a autocorrelation plot, the other is a partial autocorrelation function, okay? So which diagram looks like, so you can pick which model. So that is the theoretical part. Now let's take a look at example. This example is a time series data. It is about sales data for 36 period, maybe 36 weeks. Okay, so this is the sales data. So first, you explore data pattern. You can use Excel. Okay, this is the data 36 data. So you can create a line chart, go to insert, okay, chart, and you get the idea of this sales data. Once you get this data, you can produce a linear regression model. Okay, you can right click your mouse, add trend line, and then you have format trend line box. Toward the end, select display equation on chart, display R square. Okay, so now you have this linear regression model. Okay, so this is the method we learned before. Okay, you can produce a linear regression model and make prediction. So now we want to use ARIMA. So we are, Excel does not provide ARIMA model. So we go to the Excel or SPSS. So for SPSS, we'll go to Analyze, Forecasting, and then create traditional models. I already entered the data in SPSS, okay? So here I'm just show you the procedure. Once you enter, I actually just copy and paste the data from Excel to SPSS. So now select, so I will reset everything because I did before. Dependent variable is the cells, and we don't have independent variable. So that is the characteristics of ARIMA, no independent variables. For method, we can choose ARIMA. And the criteria, we can try, before we do that, let's create ACF and partial ACF to explore data pattern, okay? So try to, this is my data. Okay, this is the data in SPSS. I have time and I have cells. Okay, so let's create auto correlation first. So go to Analyze and then Forecasting. Then click Auto Correlations. Okay. Cells is the variable. Okay. And we want to display autocorrelations and partial autocorrelations. Okay, and then if I click options, maximum number of legs, you can select here. Let's just accept default settings, okay? And click continue, then click OK button. So this is the graph, okay, showing autocorrelation function. The line, the blank line is the upper limit and the lower limit. Any number beyond those limits are significant. So we can see the data are correlated significantly among time lag 1, 2, 3. Okay, so there are some correlation between data and lag time. And if you look at the partial ACF, again, it showed the significant spike here at the time lag 1. Okay, so now we are going to use the ARIMA model. So go back to data, go to Analyze, Forecasting, create traditional models. Just click OK button. So select cells as dependent variable. From method, select ARIMA. Criteria, let's try 2 different models. One is autoaggressive. So I'm going to use one. Okay, first order autoaggressive model. The difference D, I'll also try one. Remember when we did the Excel, when we create a line chart, the original data trending up looks like non-stational data. So we want to do difference, okay? So this is my model. And then click continue. After that, click statistics, check display fit measure, okay? LB statistics, and also check out stationary R-square. We don't need goodness of fit, but we do need parameter estimates. Okay. And for the plot, we need residue, autocorrelation function, partial autocorrelation function. Okay, and we don't need series, so we take this out. So that's it. Click OK button. And now you have this model. This is ARIMA 1, 1. The first number 1 means first order autoregressive. The second number 1 means first order difference. Okay, so we do something like yt minus 1. Okay. And the p-value for this model 0.008, smaller than 0.05, looks like this model is appropriate based on p-value method. Okay. And then if you look at the estimate, those are the parameters. Okay, you have constant 214 and you have AR negative 0.218. Okay, so based on this number, you can go back to the model at the beginning. So you get two constant. One is actually phi 0, the other is phi 1. Okay, those two numbers are the, okay, I'll highlight. Those two numbers, this one and this one, you get from SPSS. So you can write down the model, okay, those two numbers. And those are the ACF. The graph is read from bottom up. Looks like they're all within the upper and lower limit. It is confirmed the model is appropriate. Okay, so I will just copy this into OneNote so that I can analyze the result. Maybe I'll paste it here. Okay, I have my picture pasted here. So based on those two numbers, see, one is 214, the other is negative 0.28. You can write down the model. So 214, the model is YT equal to, the number is 214. I will omit the decimal, okay? So 214 minus 0.218 times YT minus 1. Okay, and plus the epsilon, the error term. So this is our model. Okay, so once you create a model, how do you make the forecast? Let's go back to the SPSS. Now, the given data have 36. If you want to forecast, for example, period 37, period 38, and you just need to click one button on SPSS. So you go to Analyze, Forecasting, Create Traditional Models. Click OK the button and go to Variables tab. So this is our model, Statistics. So see here under Statistics tab, you check Display Forecast. Click OK button. And where is my forecast? Residue. Maybe I will rerun this one. So make sure 30, maybe I will type in one, maybe 39. I want to forecast 3 period. And then analyze, forecasting, create traditional models. Click OK button, display forecast. Display forecast, that's right. And click OK button. Yeah, the forecast is here, right here. See, period 37, 38, 39. This is the forecast and also has upper limit and lower limit. Okay, and this is the ACF and partial ACF, residue ACF. Okay, in summary, what we did in this video, we introduced ARIMA methodology. In this methodology, it does not need independent variable, just dependent variable. And we introduced the different models, AR1, AR2, MA1, MA2, as well as ARIMA model. Okay. And we also used the Excel did the regression analysis. Finally, we use SPSS to create a ARIMA model and to make forecast. That's all for this video. Thanks for watching.